Hello everybody, my name is Josh. I was a computer science examiner for multiple exam boards, head of computer science in UK based schools, and now I run a tutoring business. What I've been doing with these series of lessons is I've been trying to do these kind of longer style questions which seem to be really helping people out. So this is what I've been trying to do, listening to you guys. And I'm going to be tying up the data structures unit because I did miss out a couple of them which were not relevant to every single exam board. So I'll try and chop this video up so it's relevant to the specific exam board. But just in case you're on the wrong one, Cambridge International, you only need to do linked lists. AQA and OCR, you need to do linked lists, circular queues, priority queues, and then AQA just has to do the vector stuff. So as I said, just go on to the specific video for the exam board, but I've tried to go through in the same format and going through all that kind of making it easier for you to essentially revise it. So we'll start off with linked lists. Now, one of the big things, I was actually, someone was asking me about this, and I thought I better include this. So the difference between static and dynamic, and mutable and immutable, because they kind of sound like the same thing, and I can understand why people sort of get a little bit confused by it. So let's have a chat about those. So dynamic data structures essentially means that the size can grow during runtime. Okay, and a static data structure, we have to set the size. It means that we can add things in during runtime, but let's say that the limit that we'd put on it was 10. We can go from 0 to 10, but we cannot then go further than that. Now, the difference with mutable and immutable. So mutable means that the values can change during runtime, and immutable means that they cannot change during runtime. So if you kind of think about like a tuple, we cannot edit it at all. So it is an immutable data structure. So during runtime, there isn't any, so you know with what I was saying with a static data structure, going from where we can change the size of it, but there is a limit to how much we can change it. If it's immutable, if we've already put 5 values in there, we cannot change that during runtime. We have to stop the program and then physically change it. So that's the difference between the two of them, is that static is it just can't grow past a certain point. Immutable means it's fixed in size until we stop the program and then maybe edit the data structure that we're referring to. So I just thought it'd be a really good idea to just talk about that and just make sure that you understand that. Anyway, there's a couple of things where they talk about make sure that you're able to discuss the advantages and of each of a dynamic and static data structure. So I thought I'd go through that. So obviously with dynamic data structures, with such as lists, you don't have to preset the amount. So if you maybe didn't plan for something to go over a particular amount and you need to add that in there, it doesn't matter. Your program can compensate for that because a list can grow infinitely as long as the memory allows it. Now, static data structures, they save it. I guess probably the main advantages of this is that it saves memory. If you've got limited memory capabilities, it's actually a really good idea to be able to kind of have this more efficient model, and it means that essentially your hardware can cope with some of the if you've got limited hardware, that it can cope with the different kind of data structures in there. It also forces you to plan how your code is going to work, and then you have to have a full understanding of how much is going to be working, how much data is going to be needed in each different data structure. So those are the kind of main advantages and disadvantages in there. Now, going on to linked lists then. So let's talk about what a linked list is. It's an abstract dynamic data type or data structure that uses nodes. These nodes are made up of data and the pointers. So we'll be having a little look at an example in a second of what that actually means. They're used for lots of different things. An example that I just put on there was tracking web pages visited. So it's got all of those. I was scouring through all of the different exam papers and that I was having a quick look at, and I noticed this one, and I thought it'd be really good to talk about how to add data to a linked list. It seems to be that if it's applicable to add data or remove data from particular data structures, that you need to really understand fully how this actually works. And anyway, let's have a little look at this one. So you've got a linked list, which is these cities here. And what's going to happen is Birmingham's going to be removed. So that's going to how we're going to remove data. And we're going to put York in there. And that's going to go into this particular linked list. So let's have a look at, I'll talk about it generically, but I'll also relate it to the question so that you can see the difference between the two of them, because they may just generically ask you to talk about a linked list, but the more likelihood is that they're going to ask you to apply that to a question. So first mark is node is created for a new value, which in this case is going to be York. So you get a mark just for saying that. The pointer of the node before, it changes to point to the new value. So the one which is before York is going to be, so as you can see, it goes in this order. So London, Oxford, Manchester, and then York. So Manchester is then going to point to York and is no longer going to be null. The new node either points to another node in the sequence. So say if York was in the middle and we needed it to then point to, I don't know, Oxford, we'd change the pointer in York to fit that. But in this case, York is at the end of the linked list. So we need it to point to what's called null. Okay, and that's where we go. So it's at the end, so it's just going to point to null. There's 3 marks there, even though it's a 2-mark question, but that's the whole process. To remove data from a linked list, essentially what you're going to do is the node before the node to be taken out changes its pointer to the value after. So Oxford is no longer going to point to going to point to Birmingham, is going to point to Manchester, because that's the next thing in the list. And that's how we take that out of the linked list. And I would just get a flashcard down for each of these, because it's a set sequence. It doesn't matter what they're asking about the linked list. That's just got what they're, the process and how it works. Just a little one. I did include this on the last one, but I just remember that there was a follow-on question where it was asking you to do advantages and disadvantages of linked list and hash tables. So just a quick reminder on this one, because just talking about the kind of questions that could come up. The idea of hash tables is that it does things instantly, and it generates you a value, and you can search and insert values instantly. Linked lists, you need to go through everything when you're searching, so you have to go through everything. So the process is a lot slower. So that's the kind of main advantages and disadvantages of hash tables and disadvantages of linked lists. So that's the only things which are going to be relevant for Cambridge International.